Good morning, everybody. Thank you for coming. It's always an early start at Spring 1.2 GX, so it's nice to see so many people turning out and getting up, and it's especially when they serve beer the night before, so well done. The other thing, happy Internet Slowdown Day. Although I think yesterday felt like an Internet Slowdown Day, didn't it? Huh? Yes, here, exactly, here. So we may not notice any difference today. We'll see how it goes. So welcome to this talk on Groovy for Java developers. I don't know quite what your expectations may be, but there will be live coding. And unfortunately, my fingers are still a little frozen, so I'm going to need probably help to pick up all those typos that are going to appear in the code. But that'll help you understand the code better, I think. So this isn't really a kind of tutorial on how to program in Groovy, because it's kind of hard to fit that into an hour and a half. I think other people are doing it as well. But it's more to answer a question and give you an overview. And that question is, why would you use a language called Groovy? It's stupid, isn't it? Stupid name. So, brownie points. Who is this, the character? Yes, Austin Powers. Yes, actor Mike Myers. So this is where the whole Groovy thing comes from. Well, not so much, but he popularized Groovy. So why are we going to look at this language called Groovy? So I want to start with a little bit of background. It's like when you first learn about Groovy, you say, OK, I want to find out more about it. Well, first question, what is it? You know, how does it compare to other languages? Well, for a start, it is an object-oriented language, like many others. In fact, it has a very similar syntax to Java, deliberately so. But it's also a dynamic language, and that's fully dynamic. It means you can add and modify behavior at runtime. And that's its default state. But it also, with Groovy 2, which came out a few years ago, introduced type checking. And it's simple and expressive. Hopefully going to show you a lot of examples of that. One key thing to understand about Groovy is it is compiled. Now, some people think that compiled means fast, because Java's compiled, C's compiled, you end up with pure bytecode, and that's fast. It isn't as simple as that. Any dynamic language can be compiled, and it will still generally be slower than a statically typed language. But ultimately, it's not interpreted, it is compiled. So you need to understand that even when I'm running Groovy scripts, it will always have this compilation step under the hood as it goes from Groovy source to bytecode. And then it runs on the JVM. And in fact, just to use Groovy, all you need is a jar file on your class path. OK, so it's bytecode plus the Groovy jar, and you can run Groovy code. Simple as that. So how can you actually write Groovy code? There are various ways. If you don't want to get the ID and set it up straight away, if you just want to have a little play, you can start with the web app console. So it's a Google App Engine application, and you can just type Groovy code in there and run it. And that's the URL down there. I'll show you a quick example. Then if you actually want to use it for more practical things on your machine, then you basically need to get hold of the Groovy developer kit. So this is a big distribution. There are various ways to set it up. Normally it's just a zip, download, set up environment variables, add the bin directory to your path. A lot of Groovy-related projects have this same setup. It's not particularly convenient, this one. Fortunately, if you're on Windows, there's an installer. So you just double-click the exe, bang, everything gets set up for you. The GDK gives you a bunch of command line tools, and you'll see at least a couple of them. One for running Groovy scripts, one for actually running a little editor plus output pane, and that allows you to write Groovy, run it, and see what the results are. Great for experimentation, and I'm going to be using that a little bit today as well. If you're on Unix platforms, install GVM. Has anyone not heard about GVM yet? The Groovy Environment Manager. Okay, so it's great. Right, who hasn't heard of Spring Boot? Crickets? Yes. I mean, it's hard not to hear about Spring Boot at this conference. So that is a software candidate managed by GVM. It's something that installs into your shell. Sorry, I didn't realize there was this big hum until it disappeared. That was air conditioning. Okay, so GVM installs into your shell, and it allows you to very easily install Groovy, Grails, Spring Boot, my little project called Lazybones, shout out, and a few other candidates. And you just go GVM install Groovy 2.3.6, and it does everything you need. And it's very easy to switch to different versions as well. Okay? And if you're on Unix, it's the easiest way. You can also use Brew if you're on Mac OS X, and that'll do the same job. That's if you want access to like the Groovy command line, the Groovy console. But you don't actually need all that stuff. You don't even need the GDK if you're just going to use an IDE. So Eclipse, NetBeans, IntelliJ all have first-class Groovy support. Okay, that's enough of the background. Now we actually go into proper code. So let me start with, this is I had an agenda somewhere. I'm going full Venkat mode. If you've not been to one of Venkat's talks, you have to. They're an utter experience. And I've never seen him use slides. So I don't think we'll do as good a job as he does, but we're going to go for it. Here's the agenda. We're going to look at a simple example of Groovy code, and then we're going to take a voyage of discovery into where you would use Groovy, why you would use Groovy. Okay, so let's start with if I've got an internet connection on Internet Slowdown Day. There we go. I can just go to this web page and say 1 + 1. And hopefully Groovy is not Groovy and says 3, it says 2. And we get the output down here. And that's the result of the expression. We can also do the usual hello world and execute that. If you go here, you can also view recent scripts. So people can actually save their Groovy scripts. And you can have a look at what people have been doing, what you can achieve with Groovy. Some of them are scary. A lot of them are scary, to be honest. People are experimenting and trying cool things. You may find some interesting ones in here. So here's just an example of testing simple date format from within Groovy. So yes, simple date format. The underlying class library for Groovy is the JDK. If you know the JDK, you pretty much know Groovy. Yes, Shay?
Oh, no, sorry, that was
Oh, that wasn't a question. OK, if you do have questions, feel free to put your hands up, and I'll try and catch them in the middle of the talk. OK, OK, that's the Groovy web console. So this is for experimentation. You also have, from the command line, my favorite command, Groovy console. Readable from the back, is this all good? Excellent. And this runs something you may not have seen for a very long time, a swing application. So this is pretty much the same as the web console on Google App Engine. So again, we can do 1 + 1, and we get 2. OK, so I wanted to think of a simple example and compare a traditional Java approach to a Groovy approach. Okay, now the example is, I need to go, powers of 2. So basically, we go from a list of numbers, 0 up to n, and I want 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. Okay, basically mapping the numbers from one list to another. Okay, now, given that problem, who would use a for loop? Okay, don't be embarrassed about saying yes. I'm not going to. I would go yes. If I'm in Java, prior to 8? I would say yes. So we would have something like for, this is going to be Groovy loop. No, let's make it a Java loop. Int like 0, I is less than n, int n equals, let's make it 10, there we go. And we need, of course, something to store the numbers in, so we need to add a list equals new array list. Let's see how fast I can type. I++. Okay, what goes in here? Any hints? List. Add. Seriously, need some help, people. It's too early in the morning for me.
List add I. What are we?
2 to the power of I. So we need to, math.pow. Pow or power? Power. Cool, thank you. I. And then we can do print list and see what happens. It's pow. No? Oh, right, sorry, yes, it's... It's POW. Yay. Yeah. Can we cut that from the video? Or at least, block out the faces. No one wants to know what happened there. Right, so that's a typical Java solution prior to Java 8. Okay, so the thing about this is we've spent a lot of time working out how to do it, whereas all we really want to be thinking about is what do I want? So like in Groovy, that's exactly what you do. You say, all I want is to map, that's what the diagram is showing, I effectively want to map the numbers from 0 to n via a function to the power of it. No! That's because I don't have n. There we go. 10. Does that look right? Do we know our 2 to the powers? I think we do. 1, 2, 4, 8, 16. There you go. Don't worry too much about the collect. But that's the kind of step change in expressiveness you get from switching to Groovy from Java. Now, last time I gave this talk, in fact, the last 2 times, Java 8 was already out. And of course, I have to say, yes, Java 8. Well, to be honest, Java 8, we can do .stream. This is live. I haven't tried this yet, so I'm interested to see whether it works. There we go. Map. Oh, OK, because it's not. Oh. Whoa. Whoa. I know. Let's add another one. Yeah. Wahey! There you go. Groovy using the new Java 8 API, using the much saner named method, map. That's what it should be called. Groovy, it seems, borrowed a lot of the names from Ruby, and I have no idea where Ruby got the names from. But Java 8 has a collect method. That is not the same as the Groovy collect method. So there is some confusion there. To be honest, if you're on Java 8, I would suggest that you use the Java 8 Stream API from Groovy, because you can still use these things called Groovy closures. This is what the curly braces are. They are anonymous functions. They're like Lambda functions. There are differences, but that's essentially what they are. OK? So that's a simple example of the difference in expressivity. Oh, right. So the question is this special keyword it. This is implicit. I think it's an implicit variable that there's an assumption that if you don't have any arguments for this closure, then there is an implicit single one, and you can reference it with it. But you can also say I, like so, and make it explicit. You can even, if you want, type it like so. Okay? So very similar. Interestingly, I don't want to go too much into the Groovy and Java 8 thing because I've got a talk tomorrow just before lunch, shameless plug, on Groovy and how Java 8 impacts Groovy and how you might use it. Because, as you can see, you get a similar level of expressiveness from Java 8 in examples like this. Okay? It's a very big deal. Okay, so we say, okay, this is interesting. I mean, I can write a one-liner that explains what I want to achieve without worrying about the how it is achieved. Okay? And that's a very functional approach. Functional style is typically, what do I want to do, rather than how do I go about doing it. Okay, so now we've got interest. What am I actually going to use Groovy for? You know, my manager is not going to touch it with a barge pole, especially when you told him its name was Groovy. So you still want to use it for something. And one of the classic examples, like the first introduction, is just as a scripting language. Now, there's still a little bit of, what's the word I'm after, stigma associated with scripting languages. They're not proper languages. That's so far from the truth. It's not true, but you've got the ability to run scripts. This is a script itself. It makes it very easy to do useful things. Now, many people have scripting requirements, or they have, actually, many people have scripting requirements, but they may still do things manually because they don't want to learn Bash or learn PowerShell. Anyone here know PowerShell? Anyone using PowerShell? I'm just interested. Yes? No? Kind of? Almost? Not sure? Yes. Cool. Yes, okay. So I hear PowerShell's pretty powerful. I mean, to be honest, I wish Microsoft had just thrown Bash into it and given us that option. But then, you know, developers are like that. We don't get everything we want. So PowerShell, there is a PowerShell version of GVM called Posh GVM. So check it out on GitHub if you want that variant rather than, say, installing Cygwin or msysgit or that sort of thing and install normal GVM. Right, so you either use PowerShell or Bash or Ruby, Python, any other scripting languages people use? Perl, that's a good one. I managed to avoid that one. So you've got these options, a lot of flexibility. The nice thing about Groovy is there's no context, there's very little context switch. You're programming in Java, now you want to script something. Groovy, it's similar syntax, same class library, and it's cross-platform. So let's see an example of this. Let's quit this one. So I have an example problem. I want to process some text files. So I have a text analyzer here, this file, and I have some pre-baked code at the end hidden below the line just in case I completely forget how to code while I'm up here. So what I want to do is take a text file and count the number of characters, number of words, and if there's a second argument, count the number of instances of that in the text file. So, whoa, like if I'm given a problem like that and I'm just using Java, I kind of come out in a cold sweat because that means dealing with the whole file API, which is not terribly convenient. But let's see what it looks like with Groovy. So we get our content. How do we get our content? We use the standard file class, the one that we're comfortable with. We pick up the first argument, and then, oh wow, that's it. I've got the content of the file as a string. Now I can get the char count, which is content.size, and the word count, which is a little harder. People will argue about my implementation. That's fine. I don't mind. I'm just going to split on non-word characters, sequences of non-word characters. And there we go. And work out the size. Because, of course, split gives you an array. I mean, just an array of words in this case, hopefully. Okay, and that's it. So notice I've used slashy strings. That's something specific to Groovy when you're doing regular expressions, because you don't want to have the backslash, 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 backslash D problem. Oh, sorry. So there we go. We've got a char count and a word count. If args.size equals 2, then we have another one, which is string count. There we go. And we can initialize it. What is it? Content.count. And we pass in args1. And then I can do a report. There we go. Characters, pad right. So notice, these are Java strings, Java file. Okay, we're still using the same things, but there are a lot of things you won't be familiar with. The content.count, where did that come from? Pad right? What does that do? And we do char counts like that. And we copy this one. Hopefully. There we go. Words. Word count, like so. And now, no, println is wrong. Groovy, text analyzer. Need a text file, lazybones readme, and we'll look for the number of instances of the. OK, so I'm not printing that out yet. OK, and there we go. So we've analyzed the text file. So let's have a look at that file a little more closely. So things like size method. Actually, size method applies to strings, arrays, collections. Groovy basically standardizes on size method. Okay. We also have this count method on string. We have pad right, which allows you to do alignment. Stuff that is really, really useful in scripts. Just to get the content of the file is just a text property. Okay. So you're benefiting from various features under the hood. Sort of property syntax, which looks like field, Java field access, but is actually getters and setters under the hood. And all these extra methods, such as pad right and count and the text property. All of those come from something called the Groovy JDK. So if you do a Google search for that, it will come up. And we can see, if we have a look at, let's say, string, Groovy has added a whole host of methods. Many of them very, very useful indeed. There's the count method there. Okay? All of these really make scripting with Groovy a lot nicer than you would expect if you expect it to be like Java. Okay. Now, I'm actually going to copy this code. Let's say you want to generate some XML. You actually want to make this a XML-based report. Well, we don't have to pull in any extra libraries. We can create the file, use with writer. With writer is similar to the try with resources. It will automatically close the associated stream after you've completed that piece of work inside. So you don't have to use a try, catch, or finally block. Okay? And then there's this magic thing called markup builder. And this allows us to generate XML from the language itself. This is a language structure. These are calls to methods. But because the names of the methods are not valid Java method identifiers, we have to put them in quotes. We effectively have to escape them. And I think you can probably guess what the XML is going to look like from that. Okay? Elements, char count is an element, word count is an element, and the numbers are going to be the content of those elements. So let's have a look, see what it does. Let's make sure I don't have text report. That's cool. And now we do Groovy, text analyzer, boom, and then clear, and open up our text report.xml. And there you go. Okay? And did you notice inside here, we had an if statement. So you can embed any Groovy code inside this builder syntax. So this is a very powerful feature. None of these methods actually exist on Markup Builder. Markup Builder is just saying, oh, that's a method call. I'm going to translate it into an XML element. Very powerful feature. OK. Any questions? No. Yes?
How do you deal with exceptions and outliers, things like that?
How do you deal with exceptions in Groovy in general? It's basically the same as Java. So you could wrap this whole thing in a try block. So there could be an IO exception, and then you do something within the catch block, standard. What is different is that Groovy does not require you to catch checked exceptions. They are just treated as normal runtime exceptions. So that's why I've got no try catches in there, even though I'm still using the standard Java class library. And there are some things that I just can't bear to be without if I'm ever in the Java space. One is property syntax. I can't believe they haven't added it to Java yet. And not having to worry about checked exceptions. I still do not understand what the value of requiring people to catch checked exceptions is. I really don't understand, because generally, so many times it's like catch and then rethrow, or catch, ignore. Very common. Anyone done the whole catch, ignore? I've done the catch, ignore, yeah. OK. So yes, good question. And that hopefully that answered it. Yeah. OK, so that's just an example of the Groovy language and the API combining to make scripting nice. But do you also think, well, Java doesn't allow you to do an awful lot without requiring extra libraries. And scripting is like, how do I get the libraries? How do I put them on the class path of the script? That just sounds like an awful lot of work. And frankly, it is. You don't want to have to deal with that. So I've got a second example here. And if we have a look at localhost, I have a simple REST service. Actually, it's just statically generating some JSON. But I want to query this JSON. Now, I could actually use URL, the class, and use it to pull the content across and then parse it in there. But actually, I'm going to pretend this is a real proper REST service. And I would like to use a client library for that. And the one I want to use is called Groovy WS Lite. It's very convenient and has a slimline syntax. And I want to be able to do it from a script. I want to get all those addresses and actually print them as address lines. City, comma, state, comma, country. So let's see how we go about that. And we have our REST example script. The key difference now is I have some imports, and on those imports I have this thing called a grab annotation, @grab. This allows me to specify dependencies, jar files, that are available in Maven Central. So pretty much you can pull anything you like down. So you specify the group ID, the artifact ID, except we're using different terminology here. It's group and module, plus a version. And that's all we need to do. And then I can instantiate my REST client and then do, let's print what happens when I do client.get. I'm going to add query, like so, and address, London. OK. So what's this thing in the square brackets? Address : London. Any guesses? Some people may know already. Not a list, no. So I had a list before. Actually, no, I didn't show a list. Square brackets can delineate a list or a map. So as soon as you see colons within the square brackets, it's a map. And the key is the string address. Because it's so common for map literals, you want your key to be a string, that Groovy does some funky business. So you could have, this is exactly the same as that. Okay? It's a string literal, in effect. Okay, so if I run that, no, 1 second. That's not what I want. That returns a response. Def response equals, and then I want to print response dot JSON. Okay? So it has special XML and JSON properties which you can access. And now when I run this, hopefully, very shortly, it will print that. Okay? Not that helpful, but that's basically the JSON as maps and lists, because that's all JSON really is. Okay? And some values. Let's use some internal Groovy stuff to make this a little prettier. I'm going to use something called JSON Builder and pass that map. So the root object is a map. I pass this to JSON Builder and do to pretty string. Okay? And now, when I run it, I get it as JSON. Okay? So if you've got maps internally and you want to actually just serialize as JSON, it was that easy. JSON Builder, pass in the map, and then just do to pretty string. Okay, but I still want to process this stuff. That's actually very, very easy to do. So I'm going to just copy code at this point. So what I've done is I go response.json, and then I can access properties in there. Dot addresses. Sorry, yes?
JSON Builder comes by default with Groovy?
So the question was, does JSON Builder come by default with Groovy? Yes and no. It's within a module, a Groovy JSON module. But when you run Groovy from the command line, you actually get all the core Groovy modules. So that includes the XML support, the JSON support, the Ant support. There's actually support for Ant, running Ant tasks, and all sorts of things. Okay? So you get everything. But if you want to include Groovy in your project, in a Java project, for example, then you can either say, give me everything, which is a Groovy all jar, or you say, just give me the modules I want. It's just to help slim things down if you don't need everything.
So Groovy everything includes this?
So Groovy all includes the JSON Builder, yes. OK, so right. So we access the root key as if it was a property called addresses. And then we turn this into a list of city, state, country, and then use a Groovy method called join to take all the elements and bung them together, separated by commas. And what we get is this output. One second, I'll clear. I'm actually not sure why it's pausing at the end. It's an interesting question. OK, and there we go. So this is just an example. This shows two things. One, it's very easy to process JSON data. It's equally easy to process XML data. And it shows you how to incorporate libraries into your Groovy scripts. Now, yes, this library is Groovy WS Lite, but that doesn't mean you have to incorporate a library that's got Groovy in the name. You can incorporate Jackson if you want, or any other plain Java library. It's just transparent how you work with them. OK, so I mean, that's the scripting pretty much done. So API, including dependencies, and just having the Groovy JDK. So you want actually now to start using it in projects. So what's a good option for that? Well, testing. People are generally less resistant to incorporating a new language for tests, because tests don't go into production. Now, how many people don't use or haven't really looked at Spock yet? Hands up, please. OK, cool. I'm glad, because I can show that without too many people going, oh, we know that stuff already. So You can use Groovy just with JUnit, for example. You get benefits. You get an assertion keyword that will actually work with any type of expression. You will also get list literals, map literals, a lot of sugarcoating that is really valuable in keeping tests clean. But Spock takes it kind of a step further and gives you a structure for writing your tests and some very, very neat features as well. And it's very easy to set up. So I'm normally a text editor kind of guy, but for this I'm actually going to switch to IntelliJ, also to show you how easy it is to integrate into the various IDEs. So yes, I have a Gradle build file for my Spock example, but I'm not actually going to use Gradle to build it. All I'm going to do is show you a Java class I want to test. This is an obscene way to implement find positives, but it's demonstrative of a piece of code that really does need some tests, because you can imagine that's going to go wrong every time you try to edit it. It's complex. Find positives. OK, how would you implement find positives with Java 8? Anyone want to offer an opinion on that one? Start with a stream. Yeah. And then there is a method called filter. So given a list of numbers, take the stream, apply filter, and your Lambda function is just numbers greater than 0. And then you'll just get all the positive numbers. One line! This is what it used to be like before Java 8. So if you can't use Java 8, I'm sorry for kind of shoving it down your throat how nice Java 8 is compared to previous versions. But it is. I'm sorry, it is. But you know, there is hope at the end of the tunnel. Groovy gives you all of that, plus more, and it all works on Java 6 and above. In fact, if you're on, is anybody on Java 4 or Java 5? No one? I'm hoping that everybody's moved off the deprecated versions, the end-of-life versions. OK, so I only asked because older versions of Groovy work with earlier versions of the JDK, such as JDK 5. Right, so here's our class. Note, it's Java. It's in our src directory. I'm just demonstrating that I can test Java projects without using Java in the test itself. And this is what a Spock test looks like. All you need, let's have a look at that build.gradle file. All you need is this dependency here, Spock core. Notice it's got a funky version, and that's because Spock is highly affected by the version of Groovy before Groovy 2.0. Pretty much everyone uses Groovy 2.0 now or above, so it's always this dependency. So this will work with Groovy 2.1, 2.2, 2.3. So don't worry about that side of things. And that's it. That's the only dependency you need to actually compile and build your specifications. So here we've got a spec extending specification rather than JUnit test case. And then things look very, very different. Our test method names have quotes and spaces. This is something unique pretty much to Spock. Java doesn't allow you to have quoted method names or spaces in your method names. So there's some interesting work happening behind the scenes, but it allows you to have English language describing what are we testing in this method? What is the feature? And then it does the whole, I hate to say BDD, behavior-driven development, because it's more than just given, when, then. But this is the structure. Given some initial conditions, when I interact with something, then I expect a result. Okay? Now, I have to say this is the biggest value from using Spock. Even though it has some really powerful and nice features that I'll show you at least one of, it's just that simple fact that it gives me a structure and a way to think through the test that makes it easier for me to write them, and then to actually read and understand them afterwards. So what we have is, in this case, an initial number 150, and then we have, oh, that's interesting. That doesn't need to be there. N divided by 2 equals 75. 150 divided by 2 is 75. And then we can just run it. I'm actually going to use Control-Shift F10. That's the shortcut in IntelliJ. I'm effectively running it as a JUnit test. And in fact, this is the output that you would expect from a JUnit test. It's green. There's nothing to see here, folks. It just says all tests passed. But it did run something. And I'll prove that a little later. OK, so let's actually test this number helper, because that will allow me to introduce data-driven tests. So test finding positive numbers. And we can label. Otherwise, it's just a normal method. It's just got a funky name. Given, we can label each of these blocks. So I can say, given a number helper, this actually helps me write the test, because now I've said what I want. And I say, oh, OK, helper equals new Java number helper. There we go. Auto-completion in Groovy file. It works. This is one reason why you might want to use types. So in Groovy, types are optional. You can include them or just use def, as I've used often here. But if you use types, it gives the IDE the information it needs to give you auto-completion and to verify that the types match what are expected. OK, so we have our number helper. When I find positives in a list of numbers, so helper, so we're going to assign this to a variable result. Helper dot find positives, and I'm just going to pass in 1, -1, 10, 0. Because 0 is, should that be included or shouldn't it? Well, that's why you're writing a test specification, so people know, and you can verify that that's the behavior. When then I expect a result. Only positive numbers are included. OK, and now we don't need to use any assert true or assert equals or anything like that. We just specify the expression, the truth expression, if you like. This is what we want. Result equals 1 and 10. Let's see whether that's what the implementation goes for. So Control-Shift F10. There we go. Ooh, interesting. There we go. I'll zoom in just so you... I'm not going to hide that I did something wrong. Cannot cast object square braces with class ArrayList to class... Oh, sorry, I've run out of space. To java.lang.integer. That's interesting. What I actually need to do is coerce it to an int array, because that's what my Java method, for whatever reason, is working with, int arrays. So I just use as int array and try it again. Oh, it's not going to be happy about, oh, it's going to be happy about this line. Cool, it passed. So if I try and say 0 and run it again, we should get a test failure. And there we go. And then if I zoom in here so you can have a look, condition not satisfied, notice that you get the full expression shown. It shows you result equals, and it gives you the value of result and also the result of the equal sign. And that will happen for any complexity of expression. It will tell you the state of each stage of the expression, if you like. So it makes it very easy to debug why a test failed. Except in one instance. The instance where you compare string builder output to a string. And it says they're not the same, even though they look the same. They're just different types. I mean, that's the kind of thing you get in Java as well. It's a pain. But yes. You know, other than that special case, this is what you get. OK, so this is nice. But what do we know the problems from testing and from unit testing? Well, we so often just test the happy path. I'm basically just testing a happy path. I should be testing the boundary conditions. So do I need to create a new feature method to test boundary conditions? Hell no. I'm going to parameterize my test. because that's the only thing that's going to change, is the input values and the output values. So it's very straightforward to do. We introduce a new block called where. And then I'm actually going to create a table. So I'm going to say we've got input list or input nums bar expected. That's my headings of my table. And then I say, well, if I've got, I don't want to deal with nulls. Sorry, forgive me. But I should put a null in there as well and check that null behavior is correct. I expect that I get an empty list if I pass in an empty list or int array. If I only have negative numbers, again, I expect just an empty list. And finally, let's add the happy path in as the last one. And instead of the list, I say result equals expected. Okay? So the actual variable declaration is in the header of the table. I don't have to declare it anywhere else. And now I just take that one and change that to input nums. And paste that in. There we go. Okay, cool. So what happens? This should fail, right? Because I'm still saying that I expect 0 to be in the list, and it shouldn't really. So let's see what happens. OK, so I'm getting the hello, come on, there we go. I'm getting the same error as before. But there's no real information other than the fact that it's printed out the expression indicating which test failed. And it's also not indicating how many data sets I actually executed. So that's not that useful. It can be hard to diagnose issues. So what Spock provides is an annotation called unroll. And this does a simple thing. It unrolls the data sets into separate tests, so they will appear. So I now have test finding positive numbers 2. So this is telling me it's the third data set, because yeah, we love to index from 0 because we're computers. Anyway, at least they fixed the date API, so you don't have to do months from 0 and days from 1. Anyone else find that frustrating? That was crazy. I don't know why they did that. Anyway, so yeah, that's cool. I could set this up to show like all of the tests, including the ones that passed. But that's one aspect, and that's the data-driven tests, parameterization. Very, very useful. But hell, we can go one better. Test finding positive numbers in hash, what's the name? Input nums. I'm going to put a space in there because I'm not sure there's an issue there. Input numbers. OK. Who does use Spock? Are there any people who use Spock? OK, you're going to have to verify what I'm doing, because is it a hash? Or I've forgotten now. No. OK. Failure. Input nums. I can't remember. Anyway, my good friend here is going to look it up while I go on to other things. Apologies. Embarrassing moment. Yes?
Your results array, does it care about the order? Right? If you had 10-1 instead of 1-10, would that be a pass or a fail?
Right, so the question is, in the comparison, does the order count here? Well, what would you expect if you compare two lists together?
I would expect the order would matter.
Correct, because it's a list or an array. The order counts. So yes, if you effectively do an equals between the two, it calls the dot equals method under the hood. So you're getting the expected Java behavior anyway. But yes, You might have to be a little careful comparing sets. I can't remember what the default behavior is with sets. Order shouldn't count, but yeah, you could compare those sets instead. But yeah, order does count, and that's actually what you would expect from a find positives method. It should return them in the order that they appeared in the input list.
So I just had a question.
Yeah, no, you first.
So how does Spock, before you added the unroll tag, for instance, how did Spock understand that this was a test? What was the...
Okay, so the question was, how does it know that this is a test? It's just a public method in the test case. So if actually, I don't need to look this up. 1 second. So I can put a private method or a protected method in there. That's just helper. And that would not run as a test. It's not a public method.
Okay.
So you can also include helper methods just to refactor your test cases and put shared code in either that test case or in a superclass. It's up to you. Standard JUnit stuff. There are a couple of other questions.
I guess one to follow on with what Jeffrey said.
Yeah.
How does Groovy know this is a test, or as far as Groovy is concerned, it's just a method executing, right?
Okay, yeah, so the question is, does Groovy know that this is a test? Well, as far as Groovy is concerned, it's just a class. But Spock specification is a JUnit test under the hood. So when the IDE can just run it as a JUnit test case. When you use Maven or Gradle or Ant, you just make sure that it picks up classes that have a spec suffix and treats them as JUnit tests. That's all.
So where does Spock come in here? I thought only add and roll is what introduced Spock, right?
No. So the question was, what introduces Spock? What makes this a Spock test? It extends specification. Right, and then by extending specification, you get the Spock-specific features, such as feature names that can include spaces, the given when then behavior. All of that stuff comes from just extending specification. Yeah. So yeah, okay, I'll come to you. Another question over there. Good question. Can you mock things? Yes. I won't go into it in this talk, but Spock itself has its own mocking framework, and it is really nice. I don't know if Graham Roche showed an example of one of his talks using interactions, but it's you know it's like def collaborator. I hate the word collaborator, but I think that's the standard testing one. Collaborator equals mock some interface, like so. And then you can say in the then section, 1 times collaborator dot some method. And then you can like specify, I expect that argument to be 100. Or I can say, actually, I don't care what the argument is. And you can put an underscore there and say, the underscore is like a wildcard character. You can even put the underscore there and say, I don't care how many times it's called. Effectively, you get a stub at that point, and you can get exactly the same behavior from stub. So it's very rich. I mean, I can't do it justice here. So if you do go for Spock or give it a try, check out the user guide. It's fairly comprehensive, especially on mocks. There are a whole host of different types of mocks. There's spies as well, stub, mock, spies, and Groovy versions of them as well. Okay. One thing it has trouble with is mocking classes. You know, trying to mock file is actually a really hard job, and I don't think it does that. I'm going to. I'll talk about performance a little later. Yeah, I'll come back to that. So the question was, are all Spock tests in Groovy? Yes.
So you just put in several, I guess, behaviors in one test in that data array that you put in there. That kind of flies in the face of what we thought we should. Test should be atomic and only test one thing.
Okay, so
before
Seems a couple of 1 point, 1 question. So point was, this seems to fly in the face of standard testing practice because he's suggesting that you're no longer testing one thing. And then I think you were asking whether it has the equivalent of setup, cleanup. So I'll start with that there is a setup method and there's a cleanup method as well. So yes, that's supported. For this, I'm testing one thing with different data sets. I'm testing that find positives is doing its job. But it's not testing a different thing just because it's a different data set. Well, that's my argument anyway. Yes, if you're going, possibly if you're testing a different branch of your method, then you may want to do that in a separate feature method. But it's kind of up to you. But data sets should be testing one thing, just with boundary conditions and a variety of different data sets. Is this only used for data sets? Yes, pretty much. I mean, you can see how it works. So there's flexibility in what you can do. Yeah, sorry.
Could you generically test this, say, like some number greater than 0 expected pass?
Sorry, can you repeat the question?
Could you you keep having to type in where input numbers and some set of numbers expected and some numbers. Is there any way generically?
Okay, question is, can I have to type in all the data sets like this? Is there a way to genericize it? Well, this is already it's already parameterized. You have to get the values from somewhere. I haven't tested it. This syntax may not support it, but there's another syntax which would allow you could effectively call another object to generate the data sets for you. But at some point, you have to come up with the values. Okay, question, does it take variables in here? In the table. So that's a good question. It depends where you specify them. I'm actually going to have to check. I'm not sure. I think it does. So if I put n in there, let's quickly run that. Even if that syntax doesn't support it, this alternative one where you use left shift would, because it's just normal Groovy code. It's just a table I'm not sure about. Yeah, so in this particular case, it doesn't look like it. But you can actually generate variables in the where block as well. There are some very powerful features, but I'm sorry, this is not a Spock talk. Oh, okay. Sorry, this particular error? Somebody's... Yeah, no, that's n. That's... Oh, right, okay. Sorry? Yeah? Sorry? Add it to the end? Yeah, well, I have it, I think I add it as the example. Oh, no. Okay, well, it does work. I can't remember the syntax. This has turned into a Spock talk, I'm sorry, which is very cool. But I do have other things to go on to, so I apologize. I mean, if you have any more questions, then catch me afterwards. And I'll also have a look into this one as well. Right, so that's a brief look at Spock. As I hope you can gather, they would just scratch the surface here. Lots of people have switched to using Spock, even just for Java projects. You don't have to be a Groovy project to use Spock. Okay, so that's a great addition. So, right, I have to move on. And this one's going to take not too long. So we've done the whole scripts, we've done the tests. I want to look at another option, which is including Groovy scripts into your applications at runtime. So as an example, I have a nice diagram which hopefully give you some idea of how the application is set up. So I have an application which loads a file called trades.groovy, okay? And then it runs that script against an API. So trade DSL is basically an internal API of my Java application. And that will generate stock holdings. We know what this example is. Lots of people do the whole stock thing. And that's the basic structure. So everything is Java except for this one file, trades.groovy. So I have this in IntelliJ as well, different project, DSL. Okay, so let's have a look at trades.groovy. There are different ways that you can do this. This is one of the simplest ones. We just specify a variable called trades and assign it this thing called a closure. So the closure is like the Lambda function. It's just a block of code that we can pull into our Java application and execute. Because what we want to do is make this run against our API. So we want that buy to be a method call, buy on trade DSL. There we go. Trade DSL has buy, sell, and of. So in fact, what this, under the hood, what this actually turns into is that. But it's a lot more readable without all the parentheses and quotes and everything else. So we're actually using some special Groovy syntax that allows us to do this kind of DSL-y looking thing. Okay, sort of more natural language. So that's the only Groovy in this example project. Let's close others and actually look at the application itself. That's our app. That's our main method. There's a lot here. The key thing here is our load Groovy script. We start up, we load the Groovy script, and then that's just the content. That's just a string. All we've done is load the content into a string. And then we evaluate the content of that script using an object called Groovy shell. So Groovy shell allows you to execute Groovy scripts within your applications. Simple as that.
In Java application?
So the question was in Java application. In Java application, in Groovy application, anything JVM-based. Scala application if you wanted, but the Scala crowd would probably kill you for that. I don't know. No, sorry. Closure, possibly. So yeah, anything that works on can access a normal Java API. But you do need the Groovy jar on the class path of your application, of your project. So as I said, this is pure Java, but it could equally be Groovy. So what we get out of, so it runs that, and then it's like, well, what do we do with the result? It looks like nothing's happened. Well, what happens is when I do that trades equal, that trades variable is available within this thing called a binding, which we've passed in to Groovy shell. So this allows us to provide information to the script and extract it afterwards. And then we pull out that closure, and this is the code used to run the closure against our trades DSL class, our trades DSL object. Okay? And that's pretty much it. If we look at trades DSL, it just has the buy method, the sell method, and the of method. And we have the stock holdings data. So I can, if I go into DSL, there we go, clear, Gradle, run. And this will run it against, oh, no, I need minus p CLI args equals trades.groovy. And there we go. And we've got some result. Basically, I bought a bunch of Microsoft. As soon as I bought a bunch, I assumed that I started with 1,000. So I assume I've got 1,000 of every share that's traded. And that's it. And that's the kind of example of using Groovy kind of in production without it actually being the production code itself, if you like. I've used this in the past. It was one of the very first uses for Groovy outside of using it in Grails. And we had a workflow system. So all the steps were defined as XML, and the whole workflow was defined in XML. But it was nice for very simple tasks to have embedded Groovy scripts in the XML and just execute them as part of that step, rather than having jars pulled in and having to deploy jars all over the place. But of course, it allows anybody to provide their own Groovy script and do whatever they want. OK. So that's pretty much it of the kind of special Groovy-related areas where you can use Groovy without too much friction and too many challenges from others. So what I wanted to look at next was somebody talked about performance of tests specifically. Now, it's actually a fairly large topic, but I've got an example project called Quicksort. So I didn't, OK, shoot me. I didn't write the Quicksort algorithm myself. I did just take it from the internet. So I have no idea if it does it properly either. But that's basically what I have. It's good enough. There we go. It looks complicated enough to be doing the right thing. So we've got a application that runs a Java Quicksort, a normal Groovy Quicksort, and a Quicksort using @compile static. So if we have a look, there's our Java Quicksort. It is a Java file. It will be compiled by the Java compiler. The Groovy Quicksort one, I'm just using @compile static as an annotation. And what this does is, rather than generating the dynamic method dispatch, it will actually compile to normal Java bytecode. It will actually static lookup of method, which is very fast, because dynamic method dispatch is slower to some degree. OK, so that's the app. It's not very scientific, but the numbers that you will see are of orders of magnitude that mean that it's good enough. So let's change into our Quicksort directory and run. So I'm running with, I think, 10,000, trying to sort an array of 10,000 elements. I'm not printing all 10,000, as you can probably understand, but I show the first lot to see that actually, at least it's sorting them. So there we go, 46 milliseconds for Java, 143 for normal Groovy, and 16 for @compile static. Yahoo Java. @compile static is like, what's that? At least twice as fast, 3 times faster than Java. Yes? So the question is, can @compile static apply to the Java code? No, because Java's already statically compiled. Yes, before anyone takes me seriously, these numbers are so small, and you've got JVM warm-up and stuff. Yeah, @compile static is not 3 times faster than Java, just in case anyone thought I was suggesting that. But what we do see is that these numbers, it's comparable. And the normal Groovy, 143 milliseconds, is still pretty good for 10,000 numbers. And this is for something that is really not suited for dynamic languages. The Quicksort algorithm is not good for dynamic languages. It's about the slowest thing that they'll do. Normal code is significantly faster. I will talk some more, but I just wanted to show what happens when you increase that to 1 million. 1, 2, 3, 4. I think that's 6 zeros. There we go. 200 milliseconds for Java. It's like nearly 2 seconds for normal Groovy. But at compile static is still coming out at just under 200 milliseconds. So what we're seeing is that at compile static gives you Java-like performance where you want to apply it. A lot of people will try to apply at compile static everywhere if they want to do Groovy. To be honest, I don't recommend it. I would only ever use it for those particular, where you've got hotspots in your application, where you need that kind of throughput and performance. There is an equivalent at type-checked annotation, which gives you normal Groovy behavior, but does type checking at compile time. Okay, so just to demonstrate that, if I change that to lowercase s, I actually get an error, a compile error in my IDE. Okay, I do not get that in the Groovy version. In the Groovy version, I get an underline. It's a IDE saying, I don't know about a quicksort method with a lowercase s, so I'm going to underline it. But I can't say for sure that it doesn't exist at runtime. Whereas at compile static and at type check say, that's got to exist at compile time. Otherwise, it's an error. Okay, so you get Java-like behavior at compile time. Now, more on performance. I did for the other talk I'm doing, I did a Fibonacci test. And that one is much more comparable. You know, it was like 20,000 operations a second Java, similar for at compile static, dropped down to 14,000 ops per second for Groovy, which is still pretty good for a dynamic language. Now, I also ran it with invoke dynamic support. So you can run Groovy on the Java 7 or greater with a special compile flag and a special jar called the indie jar. That ran at 20,000 ops per second. You got similar performance. So that's dynamic Groovy, but just using invoke dynamic to get similar performance benefits. Okay? So in the end, it depends on what you're doing, just like with Java, like any other language. But you don't need to really worry about it with Groovy. That's all I would say.
When you had the example of where you evaluated a script that you passed in internally.
The DSL example.
Right. So I assume you did not explicitly compile that when you kind of interpreted it.
No. So remember what I said right at the beginning? Groovy is a compiled language. So even when I run a script, there is an implicit compilation step. So yes. And in fact, create shell here creates this Groovy shell object. That allows you to evaluate scripts. But if you would like to load, Groovy files don't have to be scripts. They can be classes as well. If you'd like to load that class at runtime and then create objects from it, you can use Groovy class loader. And that will allow you to parse as a class object, which you then can instantiate. Okay? Cool. So yes, sorry for the anyone watching. The question was this, when we did this evaluation, was it interpreted or was there an implicit compilation step? It was an implicit compilation.
Do you suggest running Groovy always in compile static mode, like, so that it runs fast?
Okay, so the question was, do I recommend running Groovy in at compile static mode all the time? No, for a variety of reasons. One, it's different behavior from normal Groovy. So if you're used to Groovy by that stage, then you have to be aware of the subtleties and the differences in behavior. Two, I really don't like it because it feels like the lazy approach to me. It's like, somewhere there's going to be a hotspot in my application, so I'm just going to make everything statically compiled and hope that that solves that particular problem, which it doesn't always. You don't always need to do it. I think more critically, there are still issues around at compile static. It's a fairly new feature. It's a very complicated feature to implement because Groovy's been had like over 10 years now and has been generating a certain type of bytecode with dynamic dispatch. Now somebody's implemented an annotation which generates a completely different set of bytecode. That's quite a big feature.
You can see the performance-wise, it's a big difference between Java and just Groovy, normal Groovy core.
If you see that difference, then two options, invoke dynamic or at compile static. But I would not recommend just wholesale using it at compile static across the board. Significantly because there are still issues that you may run into or may not. But the more that you use at compile static, the more likely you will run into some of those issues. So again, I mean, I talk about this in my Java 8 talk on Thursday, but it's really about sort of a risk assessment as well. You know, if you've got critical code for your project, you know, do you want to take the risk of using Groovy at compile static everywhere for that? You know, that's a risk judgment.
Just looking at the test results, looks like just the normal Groovy comes with some sort of toll with the performance, like Java.
So yes, so his point was that normal Groovy has a toll or a performance deficit compared to Java, and yeah, it does. But to be honest, for most applications, it's almost irrelevant. You know, I've very rarely encountered an issue with it. Then if you do for particular parts, it used to be the case, just drop down to Java. Now you can add the at compile static. But yeah, the discussion of when to use Groovy, when to use Java is actually a relatively complicated one, and one that I talk more in depth about on Thursday. So I'm just pushing my other talk even more. So I hope I've helped answer some of that question, but it's a per case basis. It depends on your requirements, but I genuinely dislike the whole it's slower than Java, therefore we shouldn't use it. It's still fast enough for so many cases. Anyway, sorry.
You know, it's like you said, it's on a case-by-case basis, because you're saying, well, Java executes faster, but looks like your solution in Groovy is going to execute sooner. It's just easier to develop.
Right, exactly. So yeah, the point he made was that the Java executes faster, but you get to the code faster. You know, it's the velocity of development that counts often. That's why people switch to Ruby on Rails. And now switching back to JVM because they run into the performance issues. But you know, if you start with Groovy, switching back to Java is a lot easier. You know, it's a lot more different going from Ruby on Rails to the JVM and Java than it is going from the JVM and Groovy to Java on the JVM. So it's a very good point. And as I said, that Fibonacci example that I run, I have some results from, that, especially with invoke dynamic, there was almost no difference with Java. And that is, micro benchmarks are horrible things. They should be ignored. You may ask why I'm showing them, because people like to see them. But in this case, you saw a big difference in order of magnitude for something like quicksort. And that's just the nature of the algorithm. And I just show you that at compile static, that difference it makes over normal Groovy for that particular case. OK, great. So that's the talk about at compile static, really. And you know, you can use at type checked if you'd like the static type checking. There's apparently all the talks on Spring Boot and the like, even the Spring talks, have been having lots of Groovy. So I'm actually going to skip now the Spring Boot app. Oh no, it's so easy to run actually. Let's see. I may need internet access. So in case you haven't seen it, here's the Spring Boot application that fits in a tweet. At-rest controller, main controller class, and your request mapping. And that's it. Note that this one actually requires the Spring CLI in order to run. But you take various advantages of Groovy's lack of ceremony. Java still has quite a bit of ceremony in terms of all the qualifiers that you have to add, the public and semicolons all over the place, and still the APIs themselves are typically designed to be as flexible as possible without necessarily being easy to use. And that's where the Groovy JDK comes in. It gives you a lot of the these are common cases that you really like. You just want a simple solution. And that's what the Groovy JDK tends to provide. Java 8 has actually done a good job on improving APIs as well. So I have been very impressed with that. OK, so let's just see whether that works. Do I have Spring? Spring. You can see I run this very often. There we go, spring run bootapp.groovy. So this Spring command line, I have managed with GVM as well. And then we can do localhost. I guess this is running 8080. There we go, hello world. Wahey! Web app in a tweet. OK, and just if you're not familiar with GVM, let's have a look at the help. So we can see there are a whole bunch of things. Crash, guide, and glide. So Gradle, the build tool, Grails, web framework, Griffin, Swing, and desktop application framework, Groovy, Spring Boot, okay, and Vertex if you want to use Vertex. So very, very useful. And that's it for demos. And it's OK, so finally, get to the end. Summary. Groovy is a great cross-platform scripting language. It's the JDK everywhere. It's the same API. And if you're a Java developer, that lack of context switching is massively important. One thing I always used to think, I've got to parse some text file and extract some information. And I would go, you know what? There's awk and sed. And then I would spend 4 hours trying to work out how to use awk and sed again. And then I go, I'm sure I could have done it manually quicker. So just having a language where I know how to write this thing. I know how to write Groovy, so I can use it for a script like that. And we've seen Spock for testing. Very powerful. I really only touched on it. If you get the opportunity to go to a Spock talk and you haven't done so yet, I strongly recommend that you do. We've really seen that Java and Groovy projects seamlessly integrate. Java can actually call Groovy. Groovy can call Java. Sorry, question? Straight after this? OK, so Venkat is giving his test-driven development Groovy with Spock just after the next session, if you want to go to a Spock talk. And yeah, I highly recommend Venkat. Great speaker. OK, we have consensus, 2-1, 10:30. Anyone else want a bid? Anyone else want a bid?
I have a question.
Yes.
So when you say they can call each other easily, Java and Groovy,
yes.
Is it easier just calling a method, or by using?
OK, so question was, in what way is it easy for Java to call into Groovy? Because all you need is the Groovy jar file, and Groovy classes compile into Java bytecode classes. It's just a method call. You can use new to instantiate your Groovy objects, and then you can call the methods just as you would normally, except for something like Markup Builder. Markup Builder, which generates the XML, that uses dynamic method dispatch, because those methods don't exist at compile time. Java cannot see anything that only exists at runtime. But anything that's actually compiled into the class, you can use from Java very easily. There are ways to call dynamic methods, but you have to use an invoke helper class from Groovy and some other things. So yes, it's still doable. It's just not as transparent and not as easy.
So that's one of the advantages of Groovy, that you can create classes dynamically.
So yes, another advantage of Groovy is that you can create. It's not that you create classes dynamically, but you can add behavior at runtime. Yeah, and have runtime behavior. Yes, yes, that's a feature. It's an often misused one. More and more people actually move away from doing it, except where it makes a lot of sense. Like Markup Builder, classic example. That's where it makes sense. Other stuff, not so much. So, for example, Grails enhanced controllers. It added a render method and redirect and stuff like that. It used to add them as dynamic methods, because that was the easiest way to add stuff to existing classes. But now Then it was like AST transformations, and now it's traits. And like the Groovy JDK, all those methods added to the JDK classes are available with @compile static as well, because it's not added dynamically. It's actually effectively weaved into the bytecode. You won't see them from Java, though. You won't see the Groovy JDK stuff from Java. You'll only see it from Groovy. Whew. Does that answer your question? Excellent, thank you. One more.
Can every Java application, can we say that can every Java application be replaced with the Groovy? In other words, does Groovy has all those features provided in core Java, like multi-threading and all that sort of stuff, or it just pick and choose kind of a thing?
OK, so I think the question was, can you effectively replace a Java application with just pure Groovy? You still get access to multi-threading and everything else? Absolutely. You have access to the whole JDK platform, everything that's available in the JVM.
Groovy syntax for threading and all that stuff?
Well, let's say, so Groovy can just still use the Java class library, so you can still create threads in the same way. There is a convenience. You can do thread.start and pass a closure. That is a Groovy extension method. But typically, you would just use, you would want to use like the fork join framework with Java, or parallel streams or stuff like that. There is a Groovy-oriented library for doing concurrency, which is gpars, which does actors model, CSP, and a bunch of others. But it's, anything you can do in Java, you can do in Groovy. That's not necessarily the right thing to do.
One more thing, that you said about the checked exceptions, those are not required. But we see the instances where the checked exceptions are useful, because we got to log some of those to find out where we are missing, right? In production environment, if I have to read a file, and if the file is not available, I go hit a URL to get everything. So, but I still need to know if that file was not there. So that can only be caught with a checked exception, right? So
No. So the whole checked exception, runtime exception, the exception is still thrown. You can still catch it. You can still declare them on methods. It's just it doesn't require you to catch them. But if you need to catch exceptions, you should catch the exceptions. It just doesn't force you to. It also, the only advantage of the Java approach is that the compiler tells you that that exception happens to be thrown from within this block. But that's documented, and I feel that disadvantages of checked exceptions outweigh that one minor benefit. But that's my personal view, fair enough. So you may disagree. But yeah, it's not that exceptions disappear. It's just that one little thing that you don't have to catch them. OK, so right, better wrap up because we just right. There's an ecosystem, lots of projects. You will see some of them here this week. Cedric is doing a talk on Groovy on Android, which was like very big news. So it's unlikely that Android will be getting Java 8 anytime soon. It's still Java 6, I believe. So this will give you all of those nice features, all the stuff you can do in Groovy normally, available on Android. It should make Android development a lot nicer. So if you have the opportunity to go to that one, it doesn't conflict with something else, or check out the video. This is a very important step in Groovy's life. Got some links. Thank you.